Fugacity is a theoretical thermodynamic concept which cannot be measured or visualized directly without knowing other properties of the system. If we consider a closed system containing different species which are ideal in the sense that the systems do not interact with each other, each species takes up some volume and exerts some pressure on the system. But in reality, the pressure of one molecule will affect the other molecules and thus the properties of the system. In chemical equilibrium, we need to know how each species will balance in several phases present in the system. This is based on Gibbs free energy, that is the maximum amount of useful work that can be drawn from the system. The chemical potential gives us an idea of the contribution of each species in the overall Gibbs free energy of the system. But chemical potential has certain limitations, it is difficult to work with, and has certain limitations like when the concentrations are very small. This is where the fugacity comes in, which is also useful when the concentration of species in a mixture is very small, situations where the chemical potential is useless. Fugacity can be thought of as corrected pressure. Fugacity depends on concentration, the pressure of the system, and the interactions between the species in the substance. This is given by fugacity. The interaction between different species in a substance is given by the fugacity coefficients for the gases, the activity coefficients for the liquids, and for the solids, which gives us an idea of the reaction of the chemical species relative to an ideal state. If we have a closed system, we can predict the direction of mass transfer which will take place to reach the equilibrium if we know the fugacity. This has wide-range implications in the process like distillation, absorption, and others. Using fugacity, we can determine the optimal operating conditions. We can also determine how well there will be a mixing in the mixture at various temperature and pressure ranges. This also has wide applications in reaction engineering because we can determine how effectively a reactor is working and how much of the desired products is actually formed. So fugacity, though very complicated to understand and visualize, is a very useful tool in determining how our reactors and separators are working and has wide-scale implications.